Here for this problem we have to use source transformation to find V and how much power does the 120 volt source deliver to the circuit. So the first thing that I did was label I source, which is coming from the 120 volt, and we'll find that later. But for now, I did a source transformation on this voltage source here and this one here and turned them into a current source. So here I calculated that using I equals V over R. And here's our whole circuit now all laid out. And the next thing that I did was I found the equivalent resistance of the 20 ohm resistor, the 5 ohm resistor, and the 6 ohm resistor here. And that came out to 2.4 ohms. So that really simplified the circuit a lot more. And here I was able to calculate the total current coming through the circuit. So I did 6 minus 12 because that arrow is going downwards, and then plus 36, and that came out to 30 amps. Then here I turned this current source into a voltage source, and I did that using V equals IR, and I got 72 volts. And when you do that, that 2.4 ohm resistor will be changed from here and go up here. And here we can see there's a current going around in this circuit, and so I turn this 72 volt source into a current source once again, and that becomes 6 amps. And then we use that to find our V that goes through the 8 ohm resistor, and our V is 48 volts. Next, what I did to find the power, I first used a Kirchhoff's voltage law equation to find IS. And so here I did 20 IS plus 6 times the 1.6 ohm resistor plus 6 times the 8 ohm resistor equals 120. And that's our source right there. And then I solved that through and I got IS is equal to 3.12 amps. And then here I used the power equation P equals IV and got 3.12 times negative 120 and got 374.4 watts power delivered.